In the last part of lesson 6, we're going to build a pretty complicated spreadsheet model. It's going to require 2 worksheets. Worksheet we're going to do the work in is L3 of the one that we've been building, lesson underscore unit 6 with your last name. We want to add another worksheet, and we're going to name this worksheet estimation. And in estimation, we're going to estimate the demand curve for this data here in part 1, so that we can build this profit model in part 2. Now, what I've done is I've created a template. And what you want to do is you want to download the template first by clicking on that. I've already downloaded it, and it's right here. In the first tab, you have estimation. I want to copy that to the spreadsheet that we've been building for lesson 6. I want to paste it in estimation, and I want to do that by clicking on this corner right here between A and 1. In a PC, you want to press Control V. In a Mac, you want to press Command V. Then I want to click on L3 here, and we're going to get the template for the profit model. The profit model template is in the tab profit model. Click this corner here. PC, press the keys Control C. In a Mac, Command C. In lesson unit 6 underscore last name, in worksheet L3, you want to click on this corner here. And then in a PC, press Control V. In a Mac, you'd press Command V, and that will paste the profit model from the template using the format. Okay, so we're all set there. So let's go back to the beginning of the problem. We'll go ahead and close out the eBackpack template. Now we're going to read the problem to figure out what we're going to do here. The company 4Z produces the eBackpack and sells it directly through eComSphere, a vast online marketplace offering a wide range of products. eBackpack is made from materials that absorb sunlight to charge an internal battery, providing wired or wireless power for phones and laptops. It appeals to on-the-go young consumers who value functionality, sustainability, and tech integration. With eComSphere's dynamic pricing, which adjusts based on real-time market conditions and consumer preferences, 4Z optimizes its revenue by varying prices in multiples of 10 to encourage one-click purchases among consumers with different preferences. The data in the table below, now the quantities are in hundreds of units. This data is a random sample of information that eComSphere shares with 4Z. 4Z uses this data to estimate the relationship between quantity demanded for its eBackpack and the price it charges its diverse customers. The ultimate purpose of this exercise is to establish a single price for the next phase of 4Z's operation, brick and mortar store sales. So 4Z is going to come up with a single price for selling its eBackpack in stores like Walmart or Target. In order to do that, it needs a one price. So it's going to use the information from eComSphere here to come up with that one price to maximize profits. Okay, so in order to do that, we're going to do all the analysis in the estimation tab of our lesson underscore unit 6 Excel file and in L3 of that same file. So first we have to estimate demand, and I've got you started. I have a scatter plot here that's already formatted because we copied this worksheet in from another Excel file. We have to modify the information here. This is referring to cell B2 of the file we downloaded. Use Shift and the right arrow to highlight everything up to that first comma, and then we want to click on B2. We want to change this from B2 in the file that we downloaded to B2 in the file that we're currently using. So that's B2 right there. We want to do the same thing for the next space. After this first comma, use Shift and your right arrow key to highlight everything to the A14. We're going to change that from a reference to the original file we downloaded to this worksheet. So we're going to click on A3 down to A14. So now we have B2 of this worksheet. We have A3 to A14 in this worksheet. And then finally, after the second comma, hold down your Shift key and then go all the way up to, but don't include the comma. We want to change this reference from the file we downloaded to this worksheet. So we're going to click on B3 to B14 in this particular worksheet. There should be a comma 1 at the end here. And we press enter. And now notice when we click on this dot here, we get the purple box in this worksheet estimation from A3 to A14. We get the blue box in this worksheet estimation from B3 to B14. And then we have the word demand up there. Let's first copy this because we need to make 3 copies of this graph. The first one's going to be linear, right? So I'm going to right click on a data point. I'm going to add a trend line and I'm going to choose linear. And then I'm going to add the equation on the chart. And I'll go ahead and include the R-square too. And then I'll do the same thing for these charts. Right click, add trend line. Now the second one's going to be the power. When you click on power here, this relationship, this function here is no longer a flat line. It kind of curves, right? It curves. And then finally, we need the exponential fit. So right click, add a trend line, click on exponential. And you can see power and exponential curve to fit data that are probably not linearly related, right? And it looks visually like maybe the power one is the best fit. Okay, the last element we want to add to this, we're going to go to chart design. We want to add a title. Chart title. That's our power fit. Exponential fit. And this one here is our linear fit. Oh, we got to right click and add equation and R-square. We got to right click and make sure we add the equation and R-square. So now what we need to do is we need to bring the parameters from these equations down here. But we don't have enough decimal place accuracy. So if we go back here, we want to right click on the equation in each diagram to increase the number of decimal places by choosing Format Trend Line Label. And then change the category from general to number, and then set the number of decimal places to 6. So right up here, click on Format Trend Line Label, change it from general to number, and then add 6 decimal places. That gives us more accuracy. And then do the same thing here. Right click on that, Format Trend Line Label, change this to number, and then 6 decimal places. And then finally, on the power fit, right click on the equation. This one's in its scientific notation. So right click on the label, Format Trend Line Label, number, 6 decimal places. All right, so now we can come over here to our parameters. I'm going to copy everything from the negative 0.35 to the decimal place 314675. I'm going to copy all that. Control C. Control V. The slope is the coefficient of X. I'm going to hit Control X there to cut it and put it in the clipboard. The 211.31465 is the intercept. And then this right here is the slope. Now for the power. So I'm going to set this one aside. Now this says exponent and constant. The constants actually, I guess you can think of as the coefficient of X. Control C. Control V. And then you got the exponent right here. Control C. I want to get rid of the X. Better way to describe this is the relation parameter. And I think you can think of the first one as the location. It kind of determines where the curve is generally going to be located at in the XY plane. I'm going to change that to location. The negative number tells you the relationship between price and demand. As price goes up, quantity demand goes down. So that's why I call this a relationship parameter. And then the final one is the exponential model. Maybe I'll just try copying the whole thing here. Control C. Control V. So I'm going to get rid of everything beyond that. So that's the location parameter. And the relationship parameter is the negative number, right? And the negative number is the exponent of E. I got to get rid of the X to make it a number. Okay, so we have the location parameters and we have the relationship parameters. Now notice what happens up here. When you fill in this information, these things are filled in. And what are these things? We're taking the 450, right? We're taking the 450 here, A3. We're multiplying it by this B19. And then we're adding it to this B18. So this is evaluating this linear function at 450. Let's bring back the linear function here. So we're feeding it the price, 450. So the price is about 450. And then we go up to the line and we get something that's just over 50, right? We get 51. So this vertical line here that connects these two dots, that's 450. And this dashed line at 450 is about 51. Okay, so that's what we're doing there. We're plugging 450 into this line right there. And we get 51.7307, right? What about this number here? What we're doing here is now we're on the power fit, right? So we're plugging, for example, 450 into this curved function. So replace X here. If you can see that, we replace X. Let me change the font size to 10. Maybe you can see it now. So essentially what we're doing here is we're plugging 450 into this curved function. We're replacing X with 450. We're raising 450 to this negative power. And then we're multiplying that by this large, very large number, right? And we get something that is a little less than what we got from the linear model. We get 50.8135. Why? Because this line bends toward the origin. resulting in a slightly lower height. And then for the exponential, here, 51.1790, we're plugging 450 to get the height of this curve at 450. So what we're doing here is replacing x. We're replacing x up here at the end. We're multiplying this value of x, 450, by this negative number, and that is the exponent of e. And then we're multiplying the result by this 466.510119, right? So that's what we're doing up there. So if I click on this, we're doing exactly that. We're plugging 450 into our function. We're plugging 450 into this function. And then we're plugging 450 into that function. And that function, again, is what? The blue number multiplied by e raised to this red number times 450. We're plugging 450 into this function. And that function is what? The very large number times 450. But 450 is raised first to that negative 1.91 power. And then because we have dollar signs on the column B and rows 21 and 22, when I pull this down, and I don't have dollar signs on the A3, what happens here is these two boxes, the blue and the purple one, are frozen in rows 21 and 22, while the red box is not. As I drag that down, we're plugging different prices into that fixed function. And we do the same thing with linear. We have dollar signs that fix the blue box in row 18 and a dollar sign that fix the red box in row 19, but we allow the purple box to move down as we copy it down this column. And then finally, the same thing goes with exponential, right? We have dollar signs on the blue box. We have dollar signs on the blue box and dollar signs on the red box, which fix these in rows 24 and 25. Then we allow A3, this purple box, to move down as we copy. And then I'm going to put a big, thick border around all this. Now, in these columns, we want to calculate the MAPE. MAPE is the mean absolute percentage error. And the way you calculate the MAPE is, first, you want to calculate the error. So let me delete the ABS and the parentheses here. The error is the difference between what we observe, 45, and what the model predicts, 51.7307. That's the error. And the error is negative. Why is the error negative? Because what we observe is less than what the model's predicting. So we have an error there, right? Well, we want the absolute percentage error. So first we have to come up with a percentage. The percentage error is this difference divided by the value that we observed. We hit enter. So this right here is the error as a percentage of what we observe. But we want the absolute. What does absolute mean? It means ignore the negative sign. So we need to type ABS here with a parenthesis around this whole thing. And that will get rid of the negative sign. And then we do the same thing for power. We're using the absolute value. This right here inside the parentheses is the error. This means the error is stripped of its negative signs if they exist. And then we're dividing by observed demand. And then we do the same thing for exponential. Then we can pull those down to get all of the absolute percentage errors. The squared error is just the error, what we observe minus what we predict. And then we square that. And we drag that across. And we can pull that down. So this number is large. Why? Well, we observed 125. We predicted 108. So there's a large error there. And then we square that, right? So we get these large numbers. The squared error for power is not very big because the power model predicts 117.5120, and we observed 125. So that's not a big error. The exponential model has a very large squared error because it predicts 112 when we observe 125. The absolute error is just the error stripped of any negative signs by using the absolute value function. And we just drag this down. These are absolute percentage errors for the linear model. This is calling for the mean absolute percentage error. So the way we calculate that is we just take the average, absolute percentage errors. So the MAPE for the linear model is 0.0968. The MAPE for the power model is 0.0588. And the MAPE for the exponential model is 0.0650. We want these in percentages. So we have to multiply these by 100. Now these are squared errors. This is root mean squared error. And the word root, the letter R here, refers to square root. These have all been squared. We want to take the square root of that. So we're not only just taking the average of these, we're taking the square root of this average. That's why we call it the root mean squared error. Again, we're taking the square root of the mean of these squared errors. The square root of the mean of these squared errors. And then finally, we have the the mean absolute error. We're just taking the average of the absolute errors. I'm going to pause the video and I'll come back after I've filled in these values to see if we got them right. All right, welcome back. I've copied and pasted the values into my Alpha Math. I'm going to press enter to see if I've got them correct. Welcome back. It looks like I copied them in and got the correct answers. Now, if you notice, I have the power mean absolute error, the root mean square error of the power model, and the mean absolute percentage error of the power model, all bold and red. Why do I have that? Because this is smaller than the linear MAPE, and it's smaller than the exponential MAPE. So collectively, the errors are smallest for the power model. The same goes for when we're using the squared errors. The root mean squared error is smallest for the power model. And then again, the same thing goes for the absolute errors. The mean absolute error is smallest for the power model. So according to the the fit that minimizes model error is the power. According to the root mean squared error, the fit that minimizes error is power model. According to the MAPE, the fit that minimizes error is the power model. Because MAPE divides each error individually by the quantity demanded, it can be highly skewed during periods of low demand. And so optimizing on MAPE can result in strange forecasts. Whereas MAE gives equal weight to each error. Root mean squared error gives more importance to the largest errors. If there are large errors, MAE is preferred to the root mean squared error. If there are no large errors, root mean squared error is preferred because it is unbiased. Since the graphs indicate that there are no outliers, it doesn't look like there's any outliers, things that are a long ways away from the predicted model. Root mean squared error is the preferred key performance indicator of model error. And according to it, the power fit is the best fitting model. Now in part 2, we're going to build the profit model so that the e-backpack can be sold in brick and mortar stores with a single price. Okay, so we got to insert the parameters of the best fitting curve. And the best fitting curve was the power model, right? So I'm going to bold font that and change the color to red. Now I want the location parameter in 0 decimal places. And I want the relationship parameter in 4 decimal places. Now I don't need the commas. The relationship parameter is negative because as price goes up, quantity demanded goes down. I need the negative sign. Press enter. I'm going to just copy these and paste them right here as values. In this spreadsheet, I need the decimal places rounded explicitly. So I'm going to do this. I'm going to delete the decimal place there. And then I'm going to make sure that this decimal places explicitly, right? Okay, you need that, right? So if I were to increase the number of decimal places here, everything beyond this period would be zeros, and everything beyond the 2 would be zeros. That has to be explicitly done. The unit cost of manufacturing the e-pack pack, in my version of the problem, $233 per unit. I'm going to place that right there at $233. I'm going to put that right here. The trial price in the model is $480. So I'm going to copy this $480 right here. That's going to be the initial price for the model. And 40 seems reasonable given the values in this table, right? Now I'm going to build the model in Excel, and then I'm going to take the values from Excel and put them in my Open Math. The predicted demand, to get the predicted demand, I'm going to copy this equation here from the power model. We picked the power model as the best, right? Because it had the lowest MAPE, root mean squared error, and mean absolute error, right? So I'm going to just copy the equation here that we use to calculate the predicted quantity demanded at a price of $450. I'm going to copy that. I'm going to paste it right here for predicted demand. Now I got to modify this equation. Remember the blue box was the location parameter. The purple box was a relationship parameter. And then the red box was the price. I hit enter and I get 44.913. Now, if I change this temporarily to 450, my predicted demand is 50.799. When I change this back to 480, my trial value, when the price goes up, the predicted quantity demanded goes down. And that's, again, why we call that the relationship parameter. Now, what is my total revenue? My total revenue is going to be the predicted quantity demanded times price. Change that to quantity demanded. Because I want everybody to understand that this is a quantity. And it is in hundreds, right? It is in hundreds. Now, the total cost is the unit cost to produce times the predicted quantity demanded. And the profit is the difference between our total revenue and our total cost. Now I want to build a data table down here. I'm going to type equal and then go up to my profit. The gray boxes are all referring to this profit, right? Now I want to build a data table. I'm varying the unit price by 20, all the way down to 680. I need to highlight everything that includes the profit and these unit prices to create this data table. I need to go to home. Whoops. I need to go to data, what if analysis, data table. The column input cell is changing my unit price. So I need to go up here to my inputs. I need to click on the unit price. 480 is one of these prices, right? We want to vary them. We want to create profits at different unit prices. And then I can click OK. And notice profits. Now in this part of the spreadsheet, we want to find the maximum profit and then the best price. We're going to automate that process, right? The first thing we have to do is we have to type equal max. And then we want to highlight these values down here and press enter. So the maximum profit is $11,094. So what we want to do here is we want to compare this to the values here. And if you have, thousands of it, this is very difficult. But with just 22 of them, it's pretty easy. So the best price is 480, right? So this is going to be 480. Now, before we move on, I'm going to change the name of these cells from B26 colon to B47. I'm going to change that to profits by typing profits in this box. Now up here, I'm going to change this B26, B47 to profits. And notice as I do that, profits is a set of cells, right? And when I finish typing profits, this blue box is highlighted. Now I'm going to change this list of prices to prices. And you're going to see why in a second. To automate the process of finding the best price with this maximum profit, given this list of profits, I want to use a match function. The first thing is the value I want to look up. And I'm going to call it max profit, comma, which I haven't named yet. And I want to find that max profit in the list of profits. I'm going to just type profits here. And then I'm going to type exact match, 0. And then close parenthesis. Now I'm going to get an error because I haven't named this cell yet, max profit. So I'm going to come up here. I'm going to name this cell. I'm going to change it from B20 to max profit. When I press enter, it's going to give me the number 12. What's going on here? So what's going on here is in this red box that I've named profits, I'm going to find the value in this red box that exactly equals this value. And that's right there. So why the 12? Well, if I look at the row number here, that's row 1, that's row 2, and then I pull this down, 11094 is in row 12. This is in row 12 of the thing that I've called profits, right? It's in row 12. That gives me the row. What I want is the price. The best price is 480. 480 is the price that maximizes profit. 480 happens to be in row 12 as well. So now to convert this from the row 12 to the best price, I need a new function. And the new function is called index. The second part of index is an integer. You want to feed it a number. This number currently is 12. Match max profit with a list of profits. That is a number 12. So the second number is a row number of some array, and that array is going to be prices. So this is the number 12. And I have a list of prices here, and I want the 12th one, the 480. So when I press enter here, I'll get 480. I need to change that to currency. And I'll get rid of the decimal places. Another thing I can do visually is I can conditionally format this column. Go to home, conditional formatting, choose top 10 items. Then I'm going to reduce this to 1. I'm going to change that to green. Another thing I can do is I can type an if statement here. I can do equal if this value equals that value, then quotation mark arrow, otherwise no question mark, nothing. So if this is true, if that equals that, we're going to point an arrow toward it. Otherwise, we're going to do nothing. And because I named this cell max profit, when I drag this down, that red box is frozen at max profit. And the result of this is an arrow. I'll make it bold and lighter shade of green. So it's pointing at our maximum profit. So you can do that too as well, right? This two-way table starts with typing equal B17. Remember, B17 is our profit box, right? 11,094. We referred to it right there too, right? So this cell here, B25, inside it says equal B17. So this is pointing to that blue box, and this is pointing to that box as well, right? Now I'm going to build a two-way table. The unit cost is along the top, blue, and I'm going to change unit price to red. Then I'll change this to red and bold, and I'll change this to blue and bold. Now I want to do a two-way table. So I'm going to start here. I'm going to come over to 350, and I'm going to come down to the 800. And I want to do a two-way table, so I got to go to data, what if analysis, data table. In this column of red numbers are the unit prices. So here I need to click on the unit price. The row of inputs are the unit cost. So I'm going to let the cost vary. I'm going to click on that. Then press OK. And you're going to see this table here. Right. And then what I'm going to do is I'm going to highlight the top 5 in green by doing conditional formatting. I'm going to do the top bottom rule, not top 10, top 5 in green. And then I'm going to redo it, but with the bottom 5. Change that to 5. If I can lower my cost to 150, I'm going to change these rules. I'm going to go back to conditional formatting, manage rules. I'm going to change that to bottom 1. And I'm going to change this one to top 1. This green box is the maximum of all profits when I allow costs to go from 150 to 350, and allow prices to go from 260 to 800. Now in row 49 here, we're going to copy unit cost, right? And we want to calculate the maximum. We want to calculate the maximum profit for each one of these columns, right? So for the 150 column, we want to calculate the maximum profit. And that should be 16,552, right? And then I can drag this across. So our maximum profit in this final column is right here, right? Our maximum price in the second to last column, it's kind of hard to see it. I think it's one of these two right here, right? So that would be the price that corresponds to it. And then the maximum profit that corresponds to $250 unit cost is 10,409, which is right there. And our maximum profit that corresponds to a unit cost of $200 is $12,748, which is right there. And then, of course, you got the one here, right, at $150. Now we want to find the best price. And the way to do that is we use this index function where match is finding this value here in this purple column, right? And that right there should be row 1, 2, 3, 4. It should be 4. So if I delete this part here, if I delete that part and I press enter, this should be, now if I drag this across, this profit is in what row? 9. Right there. This profit, this maximum profit, is in row 14. Right there, row 14. This profit here is in row 20. Right there. And this profit here is in row 25. Right there. So these are the row numbers that these prices will be in. Right. So now we got to put in front of that index. And then we have to put the price. So this is our price column for this data table. This right here is the row number. Now, when we drag this across, we got to freeze column A here, right? So I'm going to put a dollar sign in front of the A's. Now, when I press enter, it should give me the price, 320, that corresponds to this maximum profit. It gives me 320, right? Now I'm going to format that as currency with 0 decimal places. Then I'm going to drag that across. And you're going to see our best price change. 320, 420, 520, 640, and 740. So a price of 740 corresponds to maximum profit. That's our maximum profit in that column. A price of $640 corresponds to maximum profit in this column, corresponding to $300 per unit. That's our maximum profit. A maximum profit in the $250 unit cost column has the best price of $520. This is the maximum profit in this column. And then 420 is the best price in this column. That profit is the highest in this column. Now, another thing we can do is we can do this. We can do the maximum profits per column by doing conditional formatting. We'll do a different conditional formatting. We'll do top 1 And then just do green. Conditional formatting, top, bottom, green. And then the final column, I'm going to pause the video to fill in all these values into my open math just to make sure that we did everything. Welcome back. I took the values from our spreadsheet. After I reduced the number of decimal places to 0 and got rid of dollar signs and commas, I inserted those into the HTML table in my open math. And it looks like I got everything correct from what we did in our worksheet. I also added some rows down here for determining what we should do over the long run. So now I'm going to work on that. This is outside of what we did here in my open math. We want to determine what we should do over the long run, because over the long run, with that profit and this price, what's going to happen is it's going to invite competitors into this marketplace. And this is our unit cost of production if we keep our current factory. If we keep our current factory and our unit costs are $233 per unit, that's fixed. And our profits will look like this. I'm going to create a graph here real quick. Insert, chart. I'll pick the one with the lines. Down here it says to change this title to that. So in the short run, we're holding our unit cost constant and we're allowing our price to vary. And when our price varies, our profit varies. I'll call this over the short run, SR. Now I want to click on the point that corresponds to our maximum profit. I'm going to change the fill to red. As we generate these profits of 11,094, that's going to invite competition, and that's going to push the prices down, and it's going to push our profits down. As the market price is driven down, our profits are going to be driven down. So what are we going to do over the long run? Over the long run, maybe we can adjust our unit cost. Maybe we can invest in more efficient factories. Maybe we can invest in more efficient ways to assemble our product. Maybe we license a factory in Indonesia, Vietnam, or China, or India. We license somebody overseas to make our product, which is what Nike does, which is what Joe Rocket does, which is what Apple has been doing, right? They assemble the product overseas. The research, the development, the marketing is all done in the States, but you have somebody assemble it in another country. So that's what we're going to do down here. We're going to find the best long-run max profit, the best long-run unit cost, and the best long-run price. So the first thing I want to do is I want to name these cells max profits. Max profit without the S is this value, right? I've named these cells max profits, right? Because we're allowing the unit cost to change. Over the long run, we can alter where our product is being produced, right? We can alter the technology to drive down our unit cost of production, right? So these are these are the maximum of the max profits, right? This is the maximum profit for this column. This is the maximum profit of this column, et cetera, right? And each one of these columns, it corresponds to different unit cost. Now I've named this set of cells long run cost. I've named this set of cells long run prices. So the first thing I'm gonna do is I'm gonna calculate the maximum of the maximum profits. So max, and then max. Profits with an S. Close parentheses. And that is 16,552. Now, what I want to do now is I want to find the column that's in. Now, it's pretty easy to see it here, right? But suppose we had hundreds of different costs here, and this was nonlinear. It'd be very difficult to find these. So I'm showing you how you could do this with more unit cost in this table, right? With nonlinearity. So right here, this should be 1. I'm going to type match. And the lookup value is going to be this, right? We're going to look that value up in the row called max profits. I'm going to put a $sign in front of the 54 to freeze this blue box right there, right? And then I'm going to finish this off with comma 0 for exact match. And then press enter. And it should again be 1, right? Because the maximum of this row is obviously that. Now, again, this is going to be much more difficult to see when you got hundreds of unit costs here, right? Now I'll drag this down and I'll redo the thick border here. So this, again, is going to be 1. Why? Because we're matching this here. We're looking for where this equals these values. Where this equals the values, the output is the column. And the column here is 1, right? Now, we're going to put in front of this index, and I'm going to type a comma. So I got index, parentheses, comma. And then here, I'm going to put long run. I got 2 choices, cost or prices. I'm going to say cost. So what this is 1. This is going to output the long run cost in column 1, which is 150. Then I'm going to do the same thing down here. I'm going to type index, parentheses, comma, and then here I'm going to put long run prices. And again, what it's going to do is this again is 1. Index long run price is going to output whatever is in column 1 of long run prices, 320. Okay, so the last graph we're going to create is a chart that graphs maximum profit on the vertical axis versus unit cost on the horizontal axis. So I'm going to copy this graph here. I'm going to copy this. I'm going to paste it down. So this is the copy of it, right? I'm going to zoom in. I'm going to move this over here. So this is fine here, right? I want to modify this chart. So I'm going to do is I'm going to grab, click on a data point. I'm going to grab the blue thing. And then I'm going to stretch it over here. Then the purple thing is going to be my unit cost. This is graphing profit versus unit cost over the long run. Because in the long run, I can vary where my production occurs. Put the corresponding best price as the label of each point. So I want to right click on here, add data labels. And then on a data label, I want to right click on it, format data labels. And then I want to check mark value from cells. I want to go from B52 to F52. Uncheck the Y value, uncheck the leader lines. And these are my prices. These are my best prices, right? And then maybe put best prices in parentheses. So what this is saying is over time, the price is going to be bid down if this is a profitable industry. If that's the case, if the market price is pushed down to 320, the way I counter that is I license the manufacturing of my product to an overseas factory to drive my unit cost down to 150. And that allows me to generate a profit of 16,552. Now, we're going to put this chart up here. That's our short run profit curve. And you can think of this as our long run profit. And then what I'll do is I'll change this dot here. Marker, fill, red. Okay, so our best choice in the short run with our production in the United States and our production cost at $233, our best decision is setting a price at $480 and generating a profit of $11,094. Now, over the long run, as prices are bid down, maybe to 320, our best decision is to have a factory set up where we're licensing the manufacturing of our product at $150 per unit. We charge a price of 320, we can generate a profit of 16,552.